Okay. So what were we discussing in the last class? VLAN. What is VLAN?
Virtual local.
Yeah. Okay. What is virtual local area network?
Virtual local area network is used to connect a few computers in an IP address.
An IP address.
In a department.
In department. Okay. Are you sure?
Like it's used to divide one network into
Hmm.
2 or 3 bits, 3 bits. VLAN, sir, VLAN.
VLAN.
So VLAN include department to
Hmm. Pratik? No. No idea. Get idea. Jacoba? Ina तुम्हें? Sir.
Virtual local area network, which is used for dividing the devices.
Devices.
Sorry. Networks for easy traffic now.
Okay. Vaishnav, are you there? Vaishnav, am I audible? Vaishnav, are you talking? I'm not able to hear you, Vaishnav.
Hello?
Yeah, bit louder.
Can you hear me now?
Yeah, bit louder is still too low. Okay, what exactly this VLAN is, Vaishnav?
It's a virtualized connection used to connect multiple devices.
Okay, like what? Like why? Why
Uh,
creating virtual networks?
to logically differentiate the network.
Okay. Mr. Pradesh?
It's like dividing a network into a smaller sections. Like yesterday, we saw around 1024 VLANs, right?
Mm-hmm.
Apart from VXLAN. I think like traffic could be controlled. For example, VLAN 2, or maybe like a subnet, I think,
Yeah.
which will isolate the traffic from one network to another network.
Oh, one.
Still, sorry, one network.
Okay.
Since we are splitting it into multiple thing like I'm trying to use a simple word like
Okay.
in one pipe we are putting a lot of small pipe, right, and regulating it outside. So traffic could be controlled. Still, I'm not very clear like how this will be different from a subnet.
Okay.
Subnet is also going to do the same thing, right? We are taking a big chunk of network and split that into multiple groups so that multiple groups are range of the idea so that we can make the best use of without wasting the IP, we can something like that.
Yeah, Mr. Bosu.
Yeah, VLAN will help us to communicate selected pieces,
Okay.
particularly which not.
Okay. Okay, what exactly the VLAN we said? I can say it's a kind of a layer 2 security. Okay, we do it on the switches. Yes, so it is a layer 2 protocol. So it should not work on the routers. Okay, and when it comes to the difference between subnetting and the VLAN, subnetting is totally different because there will be, dealing with the IP addresses. Okay, here we don't have any IP address. Here we're just playing with the MAC addresses. It's totally related to the switch. It is not anything about the IP address and all. Okay, so it is only configured in the switches, that is layer 2 and even layer 3 also. Okay, layer 3 switch and layer 2 switches. Okay, where it will be isolating some, I can say, yeah, they all will be in the same network. I don't say like we are going to divide the network here. Okay, but we are going to divide the ports logically. Port means what? Obviously, we are dividing the MAC addresses. We are separating the MAC addresses. Okay, what you have seen yesterday, we have taken some of the what do you call PC devices. Okay, so we're connected to that particular switch port. And what you have done, when we didn't added those PC devices, we added the switch ports to the VLANs. Okay, that means we are dividing the switch ports, not the actual end devices. Whatever the IP it may be at the end on end devices. You already know that we can't assign any IP address on the switch port, but we can do it on the end devices, just like we did it on the PC yesterday. Okay, we are dividing what? The MAC addresses here. We are dividing the switch port logically. Understood? You see what a VLAN is, virtual local area network. Virtually, we are creating a small networks inside that switch. Understood? So yesterday also, I think we have seen practically. Yes, we did. We did. So I'll take the same. Yeah. So Shah, what are the two port roles I said yesterday? Port roles. Which are the two ports we have in VLAN? I'll let him. So we studied dynamic.
No.
Then
Active income.
sure. We studied dynamic. So what kind of cable we use in between these two? What kind of cable this one is? Straight through. And here?
Straight.
Sure.
Put 6 to 6
Yeah.
from bottom with same device.
Okay. Now let's assign the same IP addresses. Save that one. Mr. Narendra, are you sure you joined the correct class? Narendra,
Yes, sir.
sure you joined the correct class?
Yes, sir. Yes, sir. No, today is my first class actually.
It's the first day.
Yes, yes.
It's already been a week started.
Yes, yes. Yes, sir. I can follow up the recording videos.
Yeah, who will help me to configure this VLAN here? First, let me assign the IP addresses. Okay, Bharati will help me. Bharati, are you there? I don't know the commands, how to, create a VLAN and all. Okay, you will help me. Done? Yeah. Okay, I have assigned the IP address. Now, can you just help me to create this VLAN and how to add these interfaces into the VLAN? I'm on Swiss CLI now. Okay. So which mode it is, Bharati? Which mode this one is? I said we have 3 modes, right? I did. I didn't. I did or I didn't. I did. So what are these 3 modes we have? Which mode we are in? User execution. Sure. Then how to go into the privilege mode? Enable, sure. If I type en, does it go? Sure. Does it goes? It did. Next, how to go into the global configuration mode? Execute. Good. Okay, config tree. Next, we have to add the interfaces into the VLAN. Before that, we have to create one. We have to create the VLANs. So what I'll do, I'm not going to create any VLAN. So directly I'll go into the interface and I'll try to add those interfaces into the VLAN. Okay. So let's go to the interface fast Ethernet 0/1. Okay. And switch port mode access. It should be access, right? Sure. Are you sure? Yes. Okay. And I'll say switch port access VLAN 10. Okay. Still I have not created any VLAN. Okay. But if I hit enter, okay, it says like what it said? Access VLAN does not exist, creating a VLAN 10. That means even though if I have not created any VLANs, okay, automatically it created one for me. Okay, if you forget to create any VLAN, yes, and still if you try to add the interface into the VLAN, okay, it will try to create a VLAN for you. Okay, the next is exit and interface fast Ethernet 0/2, the switch port mode access, and then switch port access VLAN 20. Okay, so here also does the same thing. Yeah. So exit and interface fast Ethernet 0/3. It should be into switch port mode access and then switch port access VLAN 10. Okay. Interface fast Ethernet 0/4 and then switch port mode access switch port access VLAN 12. Done. This is what the thing is. Now before that, I'll show you here something. I'll just go to the first PC and I'll just ping every other PCs. What I have just get 6. It is pinging. I'm in the second switch. Yes. It also ping. It will also ping. And then this last one, that is 8. This will also ping. Okay. Now let's go and configure this one. Enable config P interface fast Ethernet 0/1 1. Yeah, 1 fast Ethernet 0/1 and switch port mode access switch port access VLAN 10. So here also it does the same thing, created one. Exit interface fast connect just /2, and this should be switch port mode access, okay, and switch port access VLAN 20, okay. So here also it created the 20, and one more interface faster than at 0/3, okay. It should be switch port mode access and then switch port access VLAN 20. Then exit interface, sorry, which one? /3, okay, sorry. Faster than 0/3. Okay. So next is what? Interface faster than 0/4, and then switch port mode switch port access VLAN 20. Am I right? So exit, do show VLAN, there it goes. Okay. Is that right? 1 and 3, they should be in VLAN 10, and 2 and 4 should be into VLAN 20. Okay. And let's check here. Exit, do show VLAN. So here also it does the same thing. I mean, show you the same thing. In VLAN 10, 1 and 3 are there, and VLAN 20, it is 2 and 4. Okay. Now, do you think if I am going to ping from this PC to this PC, both are in same network and same VLAN, do you think they are going to ping, Pratik? I want to ping from this PC0 to PC4. PC0 into switch 1, and PC4 is connected to the switch 2. And both are in the same network and same VLAN. So do you think they are going to communicate? No, why? Because he nodded. Yes? You think yes? Yes, definitely. Yes. Yes. Yes or no? No. 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 Confused? Definitely yes. Yes. Online? Mr. Bosu, Mr. Pradesh, Vaishnav,
Yes, it will communicate.
will you communicate? Okay. Mr. Pradesh, are you there?
Yep.
Yeah. Do you think it's gonna communicate?
Not very sure.
What is the IP address of that one? 5. 5. This one is 5. 6, 7, 8. Okay. So if I hit enter, it says no. Why? Switches are connected. You can see both the interfaces are up configured. But what is the configuration I have to do? Okay, but they are connected, right? Via that link. Then come again. But switches are connected with each other, right? What is that? That's what I'm asking you. What is that? Exactly. What I have to do? I have not added these two interfaces. That is fast Ethernet 0/5 and fast Ethernet 0/5 of both the switches, okay, into any access port or trunk port. Okay, what I have to make this port as what? What I have to make this port as? It should be access port or it should be a trunk port. Trunk port, why?
Because in actually there will be single VLAN cable,
Mhm.
and in trunk it will be multiple VLAN.
So do you think that interface is going to carry multiple VLAN information? Whatever the 0/5 we have on both the switches, do you think it is going to carry the multiple VLAN information?
In both switches there will be two different types of VLAN. In both the switches, so we have to.
Exactly. Like we have two, what do you call, VLANs here. So here also we have 10 and 20. Here also we have 10 and 20. So obviously we have to make these ports as what? Trunk port. Okay. So how to do that? The same procedure you have to follow. That is interface path Ethernet 0/5, and then you have to say switch port mode trunk. That is it. Done. Next, go to the switch 5. Sorry, the second switch at interface 5. Interface path Ethernet 0/5, and you have to say switch port mode trunk. Okay, done. Now, do you think it's gonna ping? Yes? Hope so. It does. Okay. So what would have been happened like if I made it as an access port? अगर मैं इसको एक्सेस पोर्ट बना दो तो क्या होता? What happened?
मल्टीपल डिवाइस कनेक्ट नहीं कर पाता.
Multiple devices. What do you mean by multiple devices? This is also pinging. If you are making that particular interface as was access, then you have to add that port into any VLAN. Any one VLAN, I can say, because we are making it as what? Access port. Okay. Yeah, you can make this as a access port, but that will carry only single VLAN data. Okay. Either I have to make this as what? I mean, access port, but I have to include into either VLAN 10 or VLAN 20. Okay, if you added VLAN 10, that interface into the VLAN 10, that will carry only VLAN 10 data towards that switch. Okay, if you added that interface into the VLAN 20, that will carry only VLAN 20 data. What if I kept this interface, the switch second interface 0/5 as a same, a default? Then what will happen? I made this as what? The access port, and this as what? As it is into VLAN 1. Then what will happen? Are you getting my point? Get it? Or no? That's online. I make this switch 1 0/5 interface as a access port, and I'll add that into the VLAN 10. And this I'll keep it as it is into default VLAN. That is VLAN 1. So what do you think? How the traffic flow will be? Do you think that there will be a traffic flow? There will be connectivity between these two switches? Yes or no? Yes or no? Not sure. The first basic thing I said you when I started VLAN, what is that? Two different VLANs can't communicate with each other. I said directly here, I'm making this interface as what? Into VLAN 10, and this is I'm keeping it into VLAN 1. So both are same. Both are not same. Okay, both are different. Yes, then obviously it is not going to send any traffic towards the second switch. Am I clear? Sure. Okay. Yeah, obviously if I make this as what? Access port and VLAN 10, then it will send only PC0's data, PC2's data only towards the PC4 and PC6. Okay, other than that, no traffic will be transmitted from switch 1 to switch 2. Clear? Not clear? Okay. Okay, now we'll see some of the types, common types in the VLAN. Okay. Basically, we have 5 types in the VLAN. Yes. The first one is a data VLAN or a user VLAN, and second one is a voice VLAN, the management VLAN, default VLAN, and the native VLAN. Okay. So the first VLAN, we call it as a user VLAN or a data VLAN. What is the purpose of this one? It will carries the user generated data traffic such as the traffic from computers, printers, and the other end devices. Whatever the thing we saw now. Okay, whatever the data which is getting generated by these end devices, the computers. Okay, so this VLAN 10 and VLAN 20. So these are called as what? Data VLANs or a user VLANs. Okay, which will carry only end users data from source to destination. Okay. So this is the most common type of a VLAN used to segment and manage user traffic in a network, and it helps improve performance and security by isolating different group of users into separate VLAN. The same thing we have done. What you have done? You just kept those computers into different VLAN, just isolated traffic one VLAN to other VLAN. Okay. By creating some VLAN 10 and VLAN 20, what we have done? We just restricted this VLAN 10 data should not go to the VLAN 20 computer. Okay. So you may have to VLAN 10 for finance department and VLAN 20 for HR department. In our case, I done it was HR department and the IT department. Same thing you have. So that VLAN is called as what? Data VLAN. And second one is a voice VLAN. So what exactly this one is? It is used specifically for carrying a voice over IP traffic. So where you have heard this word, like this word, like ensuring that voice traffic has higher priority over other data traffic. Yeah, I taught you this one. Just try to recall where you studied it. Yeah, in OSI model. Where?
When it's transferring from the physical area to voice to mic.
Where we studied. In TCP header and IP header. Okay, there was a field called service type. COS, TOS, QoS. Remember, quality of service. I said it right. I said it literally. I don't think you remember or not. Okay. Yeah, forget it. I mean, don't forget it. Used specifically for what? Carrying the voice over IP. So voice over IP means what? This one is whatever the device you can see in front of you. Okay. So just to carry the data traffic which is getting generated of this one, okay, we are going to keep this IP phone into some different VLAN, because this voice data needs some separate treatment, and this will be given as a higher priority than any other data. Okay, so that's the reason what we'll do. We'll just keep this devices data into different VLAN, just to isolate this data with any other VLANs what we have. Okay, so just for the security and quality of service purpose. So what is this description? Voice VLANs are designed to provide quality of service to VoIP traffic, minimizing latency and jitter, which is really crucial for maintaining call quality, and it separates the voice traffic from general traffic for better performance. Okay, if you send the data of both voice and data VLAN in the same VLAN, then both will be fighting for what? Bandwidth. There is no any priority in that one. Okay, then you may be having the possibility of losing the data. Okay, and we can't afford to lose the voice data because it is not retransmittable. I can't repeat the same thing every time. Okay, if it is data, then that can be retransmitted. If it is a text or an image or something, okay, that can be retransmitted, but the voice we can't do that. That's the reason what we will do. We'll just keep this voice data as a higher priority and this voice data into some different VLAN. So we're not going to mix that data or voice data into a normal data. Okay. Second one is a third one is a management VLAN. So the name itself will tell you what it does. It is used to manage the devices, network devices. Okay. Used for managing network devices such as the switches, routers, and firewalls. Okay, not only these two, I mean these three, any other networking devices also. So this VLAN ensures that administrative and management traffic is kept separate from regular user data traffic. It is typically used to access and manage the configuration of networking devices securely. Okay, whatever the data which will be getting generated of this telnet, SSH, like we use these kind of protocols or tools just to get the access of the device. Okay, so then this, to send this kind of traffic, telnet data, SSH data. Okay, so we are going to create a separate VLAN that we call it as a management VLAN. Through that, we can able to get the access of the device. Okay, just to troubleshoot that one or else configure that one. Okay, so you can use any number. Yes, so for example, you can use VLAN 99 could be set as a management VLAN to access and configure the network devices like a switches. Okay, next is default VLAN. What is default VLAN? I already said about this one. What is default VLAN? Don't read it from there. Visha.
Default VLAN, it can give you all the data of data, and it gives the number one. We can change this from the default VLAN.
So I said that.
So VLAN one is default VLAN.
My question is why? What is default VLAN? And why VLAN 1 is called as what? Default VLAN. VLAN ports.
VLAN, all the VLAN are connected to default VLAN.
Or all VLANs.
Manually connect to the other VLAN.
Come again?
Manually connect to the other VLAN.
How? What configuration? What is default VLAN and why it is called default VLAN? I already said it, by default, all the switch ports or interfaces will be the member of VLAN 1. So that's the reason it is called as what? Default VLAN. And the default VLAN is VLAN 1. Okay, this is also type of VLAN only. Okay, so default VLAN. This is a VLAN to which all ports belongs to by default before being configured to any other VLAN. Okay, so usually VLAN 1 is the default VLAN on a switch, and all ports are part of this VLAN unless manually configured to belong to any other VLAN. And it is used for untagged traffic and can be a potential security risk if not changed. Okay, why it is risk? Because if the attacker get the access of this VLAN 1, then he will be getting the access of all those ports at the same time. So that's the reason you have to change the VLANs of all those switch ports if they are not used. Okay. So by default, all switch ports are part of this VLAN 1 unless specified otherwise. Okay. Next is native VLAN. Native VLAN, we have a separate topic on this one. Okay. So it is used to carry the untagged traffic over a trunk link, that is traffic that does not carry any VLAN tag. I mean, this native VLAN is what? Which will carry the untagged data traffic. Okay, I'll tell you what is and why. The native VLAN is associated with the untagged frames on a trunk link, which are not associated to any specific VLAN. The concept ensures that when there is a untagged traffic is received, it is assigned to the native VLAN, and the native VLAN is often configured to the different from default VLAN for security reason. So let's assume like okay, I'll show you something. Which is the trunk port? Fast channel 0/5. Okay, and status is trunking happens. What is the native VLAN here? VLAN 1. So VLAN 1 is not only the default VLAN, it is also called as what? Native VLAN. Whatever the data which is going without any VLAN tag, that will go with this tag. If the switch 2 is getting any data with a tag of VLAN 1, that will be considered as a native VLAN traffic. For example, we have some of the protocols. Okay, just like the CDP protocol. Okay, we are going to study everything. CDP protocol. Okay, and then VTP protocol, DTP. Okay, and STP. So these are the different protocols what we have in switching, which will exchange the data between the switches for every 30 second, okay, 10 second or 60 second. Okay, if the switches, let's suppose we have two switches here. Okay, same like what we have here. This is switch 1 and this is switch 2. This interface belongs to VLAN 10 and this one to VLAN 20. And here also we are connected two devices, 10 and 20. Whenever this switch 1 is sending the data of this first PC towards the second PC. Okay, so what it will do when this PC sends the data. Okay, I just want to talk with the one more PC which is connected to the switch 2. That is your neighbor. Okay, so it says like it just send that data towards that particular switch. So when that data comes to this trunk port, what the trunk port will do? It will add a tag here. It will add what? A tag. We call it as a VLAN tag. Okay, so for that again we have some two methods. Okay, that we are going to study it now. So this port, what it will do? It will tag it. it will tag that particular data as this belongs to VLAN 10. Okay, and that should be only sent to VLAN 10 device. Once this data goes to the switch 2, what the switch 2 will check? First, it will check the VLAN tag. Is it having any VLAN tag? Yes, yes, it is having one VLAN tag, that is VLAN 10. Yes, and after that it will check about destination MAC address. Okay, and it will send it to this PC. Understood? What if it is not having any tag? Because if the data may be of CDP, data may be of VTP, DTP, and STP. So in that case, the switch will not tag that particular data. Why? Why it will not tag? Because it has to tag it for every 30, 10, or 60 seconds. Okay, all these different protocols, they are having their own timings. For every 30 seconds, for every 10 seconds, for every 60 seconds, it has to tag and untag the traffic. So that will be overhead on these switches. So that's the reason what the switches will do, it will send it untagged. Okay, if the switch 2 is getting that data as untagged, then it will be considering it as what? It's a native VLAN data. Okay, so I also don't need to tag this particular data. Clear? This is called as what? Native VLAN. Am I clear? Am I clear? Yeah, next is native VLAN. Obviously, we have to change what? Native VLAN. We can't keep it to the VLAN 1 because the data traffic or overhead on that VLAN 1 will be really increased. Okay, so that's the reason we have to change this native VLAN. Okay, how to do that and what exactly is native VLAN and how exactly it's going to encapsulate the data, we're going to see it now. So native VLAN, it's the concept is used in a IEEE 802.1q VLAN tagging. Okay, where it is just standard for carrying the VLAN information across a trunk link between the switches or other networking devices. And the native VLAN is a VLAN assigned to an untagged frame received on a trunk port. Okay, whatever the data which is coming untagged of any VLAN, that is considered as what? Native VLAN data. Okay, So this is a default VLAN for untagged frames. Like on a trunk port, any frame that is not tagged with a VLAN ID that is assumed to belongs to what? Native VLAN. Okay, just like this kind of a protocols, CDP, STP, VTP, DTP. So these are some by default running protocols on the Cisco devices. They have to exchange the packets between the switches, like hello packets. So some other packets will be getting exchanged between them. Okay, so for exactly like 30-second or 10-second or 60-second, switch will not be able to tag and untag this kind of traffic. So that's the reason what the switch will do. It will send it directly without giving any tag. Okay, and if the destination switch finds that it is not having any VLAN tag, then it will also consider it as what? It's a native VLAN data. So native VLAN is typically VLAN 1 by default on a Cisco switches, but it can be reconfigured. Yeah, we have to reconfigure it. We can't keep it to the VLAN 1. Okay. What's the purpose of this one? It ensures the backward compatibility with the devices that do not support a VLAN tagging. For example, it is useful for what? Managing control traffic like CDP, Cisco Discovery Protocol, and Spanning Tree Protocol. So just to manage the traffic of these kind of protocols, we use this untagged, what you call, data traffic. Okay, that is called as what? Native VLAN. And one native VLAN per trunk port. We can't keep multiple native VLANs on a trunk port. We have to configure only one per trunk port. Okay, that is mandatory. So each trunk port can have only one native VLAN, and it is configured using the switch port trunk native VLAN command. Why it will, I mean, it should not have the multiple native VLAN? Because let's suppose like on the switch one, I kept the same VLAN one as what? Native VLAN. Okay. On second VLAN, sorry, second switch, I configured it as a VLAN 100 as a native VLAN. Okay. Then what will happen? Just consider on this switch one, we have a VLAN as a data VLAN. Yes. And if this switch is sending the data, okay, as untagged data traffic, then that will be sent only to this PC. Okay, so that's the reason we have to have same, what you call, native VLAN on both the ends per trunk port. Okay, otherwise VLAN data leakage may happen. Clear? So no tagging for native VLAN traffic, like frames in the native VLAN are not tagged on the trunk links unless explicitly configured to do so. Okay, yeah, that too, if you want to tag with any VLAN ID, yeah, obviously you can do that one, but nobody will do that one because that will be again increasing the overhead or traffic on your switches or even the trunk link. Okay, why it is increasing the trunk link, sorry, the overhead or a traffic? As I already said you, the different protocols will be running on all these switches. Okay, again, they will not be again busy with the tagging and untagging of this, what do you call, protocol traffic. Okay, for every same the timing as said you. Yes. So how exactly this native VLAN works? First one, while sending the traffic, when a switch sends the traffic from a native VLAN across a trunk link, it does not add any kind of VLAN tag. Okay. So once the untagged data received at the second switch, okay, if the switch receives an untagged data frame on a trunk port, it assumes that this frame belongs to the native VLAN. Okay. But some cases, the native VLAN mismatch may happen. So if that mismatches, then what will be the issue? What will be the problem? As I already said you, if the two switches have different native VLANs on a trunk link, it can lead to what? VLAN leakage. Same thing I said you. On switch one, if you kept The VLAN 1 as a native VLAN, and the second switch, if we keep the native VLAN as a VLAN 100, then all the traffic of this VLAN 100 which will go to one particular device. Okay, so again that will be override on that particular end device, I can say. Okay, in that case the native VLAN data leakage may happen. Clear? Where the traffic from one VLAN appears in the another VLAN. Yes. So to tag and untag this kind of a device, sorry, the traffic, we have two methods here. One is what? ISL. This is Cisco's very own proprietary protocol. And second one is the IEEE 802.1q. Okay, you can see here. If two switches have different, the inter-switch link ISL and IEEE 802.1q are both VLAN tagging protocol used to manage VLAN traffic across a trunk link between the network switches. Okay, first one is what? ISL, and second one is a 802.1q. This is a Cisco proprietary, and this one is open standard. What do you mean by Cisco proprietary? Do you know what do you mean by Cisco proprietary? Cisco proprietary means what? These kind of protocols which will work only on the Cisco devices, not on any other vendor. Just like Juniper, okay, any other vendor, they will not work on those devices. It will work only on the Cisco switches. And open standard means what? It works on every vendor, multi-vendor supported, okay, including Cisco. Yes, it works on both Cisco and non-Cisco devices. And even Cisco prefers 802.1q method only. Why? Because, yeah, even though they are having their own protocol, but they will not use this one. They always go for the .1q method. Why? We'll discuss it now. Okay, first one is what? Standardization on, what is the standardization on both this ISL and 8.1q? So ISL, already said you, it's a proprietary protocol developed by the Cisco. Okay, it is used primarily on the Cisco devices to tag frames on a trunk link. It is not an open standard and it is exclusive to Cisco equipments. Same thing I said you. And .1q, it's an open standard defined by the IEEE, Institute of Electrical and Electronics Engineering, okay, engineers, and it is widely supported across different vendors, making it more flexible and interoperable than the ISL. So everybody go with this .1q, okay, not ISL. Not just because of this proprietary or standardization, we have a big reason why we don't go for the ISL. Why we'll go with the .1q? That is tagging method. Okay, so in the ISL, it encapsulates the entire Ethernet frame with a Cisco defined header. What the ISL will do? It will be having its own ISL header that is of 26 bytes. 26 bytes of header and 4 bytes of trailer. Okay, it's a header. So total it is making it like 30 bytes. So what this 30 bytes will do? It will take the whole Ethernet header frame and it will encapsulate that within this one, within this 26 byte header. Okay, making it the header size more. What is the Ethernet header size? 14 bytes. So again, it will be added with this 30 bytes. So making it as what? 44 bytes. Understood? So what the ISL will do? It will encapsulate the entire Ethernet frame within this Cisco defined header, like effectively creating a larger frame, and the original frame is completely wrapped into a new header that includes the VLAN information. Okay, so obviously that is a like It's going to add the 26 byte tag to the frame, which contains the information about the VLAN ID. Just to give the VLAN ID, okay, it is going to add 26 bytes of header. Okay, but that is different with the .1q, that is open standard. So it doesn't have its separate header. It will use the same Ethernet header, okay, and it is going to add just a 4 byte information, 4 byte VLAN ID. Okay, you can see here 802.1q. It uses the insertion of a 4 byte tag in the middle of the Ethernet frame. So can you just tell me like what are the different fields we have in the Ethernet frame? Only Ethernet header. Yes, Mr. Pradesh, what is the header of Ethernet? What are the fields?
I think it is the first one will be I think the sync will come. I think sorry, preamble, that one, and
Okay.
then destination max, source map, then type, then data payload,
Okay.
then check sequence, the last one,
Okay.
trailer.
So the actual Ethernet frame is having only 3 fields. One is a first one is what? Destination address, and second one is a source address, and third one is a ether type. Okay, so these are the 3 fields we have in Ethernet header. Okay, so what this 802.1q encapsulation method will do, it will add its 4 byte header between this source MAC address and the ether type, okay, or a length. Yes, so it's going to add its small data or VLAN ID between these two. Between these two means what? The source MAC address and the ether type or the length of the Ethernet header. Okay, it is not going to add its own header just like the ISL do. It will not add its own header just like what the ISL do, just to increase the header size again. It will not increase that much. So it will just take that 14 byte data which is coming from the Ethernet header, and it will just add its 4 byte into that one. So just making it as what? 18 byte longer. How much it will be? 18 byte, right? 14 plus 4, 18 bytes. Am I clear? So this is the biggest reason why we are going after this 802.1q. And yeah, middle of the Ethernet frame, like the data tag is inserted between the source MAC address and the ether type or a length field of the original Ethernet frame, where the 4 byte tag includes like 12 bits VLAN ID field that identifies the VLAN to which the frame belongs to. Okay, next is frame size. As I already said you, what is the frame size will be? What is the frame size of the ISL? 26 bytes and .1q. It's a 4 bytes. So frame size, it adds a 26 bytes header to each frame, making the total frame size as a larger. Yes, so this can lead to increased overhead. Overhead means what? What do you mean by overhead? It's traffic. Okay, traffic or overhead, that means processing load on that particular device. Okay, that will be increased. Yes, which could impact the network performance, especially if the network is handling a lot of traffic. And .1q, it is having, only going to add 4 bytes of tag, which means the frame size increases much smaller as compared to the ISL. Okay, again, results in less overhead and more efficient uses of the bandwidth. Clear? And the compatibility, how compatible with each other, like the devices on different devices. As I already said, you ISL is what? Cisco proprietary. That means it works only on the Cisco devices. And .1Q, it's an industry standard supported by all modern network equipments from various vendors, including Cisco, Juniper, HP, etc. Okay, which will support, suitable for heterogeneous network. Next is, what is the VLAN ID range? So yesterday I've shown you like ISL range. What was the ISL range? Well, VLAN ID range. ISL. Okay, VLAN ID range. It supports VLAN ID in a range of 1 to 1005. Okay, it is smaller range than compared to .1Q, and .1Q supports whole 1 to 4095. Okay, which is a larger number of VLANs to be created. Okay, next is trunk link configuration. So ISL is typically used on Cisco devices where trunking is enabled via ISL encapsulation. Configuration usually requires an explicit selection of the ISL on the trunking protocol. Okay. Okay. So we don't use this ISL. Yes, still if you want, you can use that one, but explicitly you have to configure it on the devices, on the trunk port. But always, by default, it will be using the .1Q encapsulation method. That's the default one. It's commonly used in a modern network and often configured as a default trunking protocol on many switches. And it's more flexible and widely supported across the different devices. Okay. So tags, I already said you, it uses a 26-bit stack and it only uses a 4-byte tag. And overhead, obviously the ISL is going to increase the overhead because it is going to add the 26-byte tag, and the .1Q, it will be having the minimal overhead because it is going to add very small data. Okay, that is of just a 4-byte tag. Okay. Now I'll just show you like how to change the VLAN of native. So currently which is the native VLAN? Enable config T, do show interface trunk. Here it is. One is a native VLAN. Okay, so just go to the interface of Ethernet 0/5 and switch port trunk native VLAN 100. Okay, this is the command just to change the native VLAN. Okay, I just made it as a enter. You'll get a beautiful message here. Okay, just wait for that one. Yeah, there it is. What it says? Native VLAN mismatch. That means native VLAN mismatch discovered on fast Ethernet 0/5. Okay, currently it is having 1 as a native VLAN and the other end it is detecting 100. Okay, so that's the reason mismatch is happening here. Okay, for that, what I have to do? I have to configure the same here also. Interface faster than 0/5 and switch port trunk native VLAN 100. Okay. So here also must have got the, yeah, here also must have got that message. Okay. Local it is having a native as what? 100 and other end it is getting 1. It is all because of this CDP protocol. We will discuss what exactly is the CDP protocol later. Okay. Now if you check show interface trunk. There it goes. What is the native VLAN? It's a 100. Okay. If you check it on switch 2 also, It will be the same. To interface trunk, there it is. Native VLAN is what? 100. Clear? This is how to change the native VLAN. Am I clear? Sure. Okay. Now we will study one more protocol, that is a DTP, dynamic trunking protocol. Okay. So what exactly this one is? Any question with this? No? Online? Any question about this VLAN or native VLAN? Mr. Bosu, Mr. Pradesh, Vaishnav? Narendra, are you getting something?
Yes, sir. Yes.
Okay. Next we have DTP. Okay, it's a very small protocol we are going to study now. Okay, and this is really important when it comes to switching part. Yes. So DTP, dynamic trunking protocol. Dynamic trunking protocol. That means it is totally related to what? What we have seen till now? We were making the port as what? Either access or trunk manually. But you can't do it every time, right? Okay. So I have shown you there that we have three options. One is what? Access, and second one, I said you, we have a separate protocol on this one. We'll study it later. Okay. And last one was a trunk. We studied these two, access and trunk, manually how to make that interface as either access or a trunk. Now we'll go with this dynamic one. Dynamic trunking protocol. So what exactly this one is? It's a Cisco proprietary. It's a layer 2 protocol used to negotiate trunking on link between two Cisco switches and to automatically form a trunk if both ends support the parameters. Okay. So what will happen? Let's suppose we have two switches. Okay. They are connected through a trunk link. Yes. So switch 1, this is switch 2. And by default, this switches will be running with a dynamic DTP, dynamic what you call port role, that is a dynamic auto. Okay, they will be running with dynamic auto mode. That means they will be always ready for the negotiation. Negotiation means what? Negotiation means what? If I'm getting any request from the opposite end, I'll be ready to become what? A trunk port. Okay, we have two modes here. Actually, we have two modes. One is a dynamic desirable and second one is a dynamic auto. Okay, we'll see it now. So DTP works only on the Cisco devices or devices that support this particular protocol. Okay, that's why I said it's a Cisco proprietary protocol. And in multi-vendor environment, DTP should usually be disabled. We don't find this kind of DTP protocol and any other vendor. We can find it on only Cisco devices. Some key functions of this one. This negotiates whether a port should be access or trunk. Okay, this DTP will help us to make one port as what? Either access or a trunk port dynamically. Yes, it helps in automatically configure the trunk links without manual intervention. And only operates on the switch ports, not on the router ports. I said you, this trunking will be working only on the switch ports. Okay, that's the reason they call it as a layer 2 protocol. Okay. As I said you, we have some modes here in the DTP. Those modes are like access mode, trunk mode, we already studied these two. Next one is, I said dynamic auto, dynamic desirable, and the last one is a no negotiate. Okay. Now we studied what exactly this access is. What? It forces the interface into access mode. Access mode means obviously it is not a trunk. Okay, that will be non-trunking. That means it does not send any kind of DTP request. Okay, and trunk means what? It forces that particular interface to be what? A trunk port. Okay, I mean it sends the DTP packet. And what is this dynamic auto? Dynamic auto is kind of a passive mode of a switch port. Okay, where it will be waiting for the request packet from the opposite end. It will always be ready for what? Negotiation. Okay, once if I get the request from the opposite end, then I can be what? Trunk port. Otherwise, I'll be the same. Either I'll not be the access port or the trunk port. I'll be the normal port. Understood? So that is called as what? Dynamic auto. If I'm getting any request from the opposite end, immediately I'll become what? Trunk port. Till then, I'll not. Okay. That's what the dynamic auto. It's a passive mode which waits for the DTP frames. Will become the trunk if the other side is dynamic desirable or a trunk port. Then only the DA port become what? Trunk port. Otherwise, it will not. Okay. Next is dynamic desirable. So actively tries to convert the link to a trunk port. Okay. Just suppose like we have these two switches. This is my DA and this is my DD. Okay, that means obviously it is going to be the trunk port. Then it will not keep quiet. Okay, it will not be quiet. It will send a request towards the opposite port where it is connected with. Okay, it will ask to the opposite port just be trunk port. Dynamically it is done. Okay, so that's the reason they call it as actively. It will try to convert the opposite link as a trunk port. Then by sending what? A DTP frame. And no negotiate means what? It is going to disable the DTP negotiation on the port. Okay, like no DTP frames sent or processed, manual trunking required. So if I'm configuring this as a DD, but I'm going to give it as a no negotiate. What do you mean by no negotiate? If I say no negotiate on this particular switch port, then it is not going to send any kind of request packet towards the opposite port. Okay, either it should be access port or it should be a normal port. It will not become what? Trunk port until you manually configure it. Understood? So this is what the trunking process, how it works dynamically. Okay. So in which case the trunking will happen, in which case it will not, we can see here. Let's suppose we have these two switches. Which one and switch to? Okay. And okay, now start answering. This I made it as an access port. Okay. And this also I made it as an access port. Does the trunking happens? Does the trunking happens? Yes or no? Sure. No, why?
Like we go to the that VLAN only.
That VLAN.
Means in switch one, it can give the tag of VLAN as tag. So in switch two also it will go to there only, not other VLAN.
See, manually I'm making these ports as an access port. Then obviously we don't have any chance to make this link as what? Trunk link. Okay. Manually I said like you have to be the access port. Okay. Now, already. Why?
This port doesn't need a transport the content data.
Because manual has said like you have to be what? Access port. Even though if it is having the opposite port as what? Trunk port. Okay. Even though if it is sending the request packet towards the access port, it will not receive it. It will not receive any kind of DTP packet to become what? Trunk port. Because it will say like administrator said me to become what? Access port. So I will be allowing only one VLAN data. Understood? So in this case, the trunking will not happen. And now, why? Because manually I made these two ports are trunk. Then the link will be trunking link. Okay. Now, sure. Are you sure? Both are dynamic auto, dynamic auto. Yes. Yes or no? Don't think much. Yes. Be confident. Yes or no? No. Okay.
Cisco switches.
Forget about the switches. Yeah, they are Cisco switches. सब Cisco ही है, हम Cisco ही पढ़ रहे हैं. Don't worry. ठीक है? Yes, Pratik. Trunking happens. Okay, good. Yes, Bharati. Don't have any idea. Yes. Murali. Yes. No. Yes. Online, Mr. Bosu. Does the trunking happens here in between these two switches? Mr. Bosu, are you there?
Yes, yes.
Okay. Narendra. Mr. Pradesh. Pradesh, Vaishnav, Narendra. Am I audible?
Yes, you are audible.
Why? Yeah, trunking will not happen. But why?
Support needs a request to predictable.
How you said yes?
I thought both are not enough.
Yeah, both are auto. I said you guys that auto will always will be waiting for what? Request. It says like मैं खुद से ट्रंक नहीं बनूंगा. ठीक है? जब किसी और ने मुझे बनने के लिए कहा तभी मैं बनूंगा. It has to get what? A particular request packet from the other end. Then only it will become what? A trunk port. Otherwise, I'm not going to be. I'm going to be the same. And both are what? DA. Dynamic auto, dynamic auto. Nobody is going to send what? DTP frame or DTP request. Then how the trunking will happen? Am I clear? Are you sure? Online?
Yes.
No. My question is, does trunking happens here in between these two switch or not? Yes, it does. Yes, everybody? Yes or no? Why? Because the DD will send the request towards the DB. Then obviously trunking will happen in this case. I'll configure this interface as what? Dynamic desirable. Okay, and obviously dynamic desirable will send the request packet. But I said that no negotiated with the opposite port. Do you think the trunking happens? Yes or no?
No.
Sure. Everyone? Yes. होगा.
The DDA is non-negotiable.
Yeah. No. Not happen. Because I'm telling this interface as what? Yeah. तुम हो trunk port. पर चुप बैठो.
ये बंद है.
हाँ, यहाँ पे बंद कर दूंगा ना मैं. ठीक है. I'm stopping it here. I'm telling this interface as don't go for the negotiation. You can be trunk port, but don't send a trunk request to the other opposite end. समझ गए? So this is no. Clear? So these are some different.
Both are DD.
Both are DD, then obviously the trunk port will
One is
happen.
non-negotiable.
Obviously you made it as DD. Why you need the request? Done. Okay, you can see here the same compatibility. Access, trunk formed? No. Same thing I said you, trunk. It's a manual one, then trunking will happen. Dynamic auto. Obviously no. I said the same thing. Dynamic desirable. Yes, obviously. Dynamic desirable. Yes. Trunk and dynamic auto. Obviously, trunk is going to send the DTP frame towards the opposite. Then it will happen. Trunk, dynamic desirable. In that case also, yes. Okay. So these are some different possibilities what you can have a dynamical. Okay. So let's do it on the devices. Better I'll take two other switches. Yeah, do you think they are, this link is trunk now? Yes, sure. It says no. Here also it says no. Then that means not yet trunking happened. Okay. So as I said you, DTP will send what? Hello packets for every 30 seconds. Okay. And dynamic trunk timeout is what? 300 seconds. That means if the opposite, if the opposite device which is not sending any kind of what traffic towards the second switch, then the trunking will be ended. Okay. Now what I can do, I'll go on this switch 2, the first switch, and config the interface of fast setting is 0/1, and manually I make this as what? Manually I make this as what? Trunk port. Okay, switch port mode trunks. Done. If you want to see exit, do show interface trunk. There it goes. Faster than 0/1. Okay, status trunking, and with which mode? On mode. On mode means what? Manually you are doing it. Okay, which encapsulation method is using? 802.1. Okay, and the native VLAN is what? 1. I have not changed it. Okay. Now if you go at the opposite switch, how it became? I didn't run any kind of commands here, right? How this became trunk port? Because of this one. As I already said you, dynamic auto is a default mode which will be running on the all switch ports. Okay. Opposite, I made it as what? Trunk. That trunk port immediately sent the DTP request. Okay, and it accepted that one and becomes what? Trunk. And again, this is also using the same .1q encapsulation method. This is the default one. Okay, on any vendor. Am I clear? Done. Now, what I will do, I'll just make this as what? Yeah, interface switch port. Mode dynamic. Okay, if I say question mark, it will be giving you two modes. One is the auto, second one is the desirable. What if I make it as a auto? What if I make this as an auto? You can see here, both interfaces are live in an inconsistent mode. Okay, you can't see both interfaces are up here. Okay, where is that? Exit and do show interface trunk. Do you see any trunk? Do you see any trunk? Because both are into dynamic auto. So here also you can't see the trunking. Okay. Now what I'll do, I'll just make this as what? Dynamic desirable. Happened. Okay. It is because of what? Desirable, I made it. Okay. With the help of 802.1q. Status is what? Trunked. Yes. If you go at the other end, they're all set walking. Because of what? Auto. Okay. So this is what the trunking is. By using both. So you can use all of them whenever you're practicing, right? You can use all of them. Okay. And switch port, no negotiate. think command rejected because working in dynamic status. Okay, do you have any idea like when we can use this no negotiate? When we can use a no negotiate? Okay. Let's suppose we have a switch, our own network switch, okay, and a genius attacker will come like you guys, okay, and he will connect his switch to your switch, okay. Then if it is kept on a dynamic auto, okay, what will happen? That is also, he is also having switch, okay, that will be sending what? Request packet towards you, okay. Then what will happen? Trunking will happen. That means he can steal or monitor all your data which is flowing on that particular device or a switch, okay. Just to stop this one, what we can do, whatever the ports which are not being used, okay, whatever the ports which are not being used, on that port you can enable this switch port no negotiate, okay. Even though it is getting the DTP request packet, it will not be able to what? Become a trunk port. Understood? Clear? So this is what? It's kind of a mitigation of that attack, I can say. Clear? This is where we use a no negotiate of the switch port. Clear? Am I clear? Okay. Yeah, there is a configuration. While you're practicing, you can use this one. Okay, it is already recorded. Okay, we'll end it here today. Yes.